Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at the purpose of spanning tree protocol. We'll be discussing redundancy in layer 2 switch networks, spanning tree protocol, STP recalculation, issues with redundant switch links, layer 2 loops, broadcast storms, and finally we'll take a look at that spanning tree algorithm. This episode is part of my series on switching, routing, and wireless essentials. I'm Kevin here at KevTechify. Let's get this adventure started. In layer 2, we look to see we need redundancy. We always hear we need redundancy. If our systems go down, we're going to lose so much money in parts built and customers handled, customers sold. Basically, if your system goes down, you can't make money. Redundancy is ultimately important in today's world. I keep hearing numbers thrown around. It used to be that $10,000 an hour we're going to lose if our network goes down. In today's world, I'm thinking that's mostly false. Reason is here. If you're in a small veterinarian's office and your computer network goes down, there's a good chance you'll still be able to operate and proceed. You may have to bill patients the next day after their visit or something like that, but you'll still be able to go forward. Take the other extreme, something like an automobile manufacturing line, where if their network goes down, it's not tens of thousands of dollars an hour, it's hundreds of thousands of dollars. It could be even close to $1 million an hour if that full operating line goes down because of a network failure. And to have redundancy up there to make it so that these networks don't go down for whatever reason, that's part of your job as a network administrator. Now, what we do here is we add additional paths where data can travel, that if one switch goes down, we can still get around there. Now, adding these physical paths are great, but we also have to add some logical redundancy in there. And we're going to show you how spanning tree protocol goes about and helps us get that logical redundancy. If we add in multiple paths to a network or to a destination with layer 2 devices, it's possible that a loop could occur and this data will there sit and circle and circle and circle. We'll talk about how that happens. And then what we need here is we need a loop-free topology, but also give us that redundancy. And we'll go through and we'll show you how to do that here in the coming slides. Now, spanning tree protocol here. Spanning tree protocol allows us to have multiple paths to the destination at layer 2. Once again, remember, layer 2 is our MAC address. We're not dealing with anything in a layer 3 address where we're looking at IP addresses. But in order for PC1 here to get to PC4, there are 2 paths in this network. First path right here, PC1 up to switch 2, to switch 1, to switch 4. That's one possible path. The second path is up to switch 2, to switch 3, to switch 1, and then to PC4. One path is quicker, but both paths will get you to your destination. What spanning tree protocol does is it figures out what are the routes, what's the best route, let's route traffic that way. Then if something happens, we will then fall back to that secondary route. Spanning tree protocol compensates for a failure by doing a recalculations. When a network goes down, in this diagram, the connection between switch 1 and switch 2, that went down right here. Once that goes down, and whatever the reason is, maybe somebody unplugged one of these connections here, maybe a backhoe came through here and cut the piece of fiber. Whatever it is, switch 2 and switch 1 no longer can directly communicate. And so spanning tree protocol now says, okay, this link went down, let's reroute the traffic around that broken link and get our information, get our packets to the destination. There are some problems with having switches at the layer 2 and adding in redundancy. Redundancy, it eliminates that single point of failure where if that one switch goes down, your entire network goes down. Some companies, they can handle that in a small environment with a handful of PCs, your home network. Yeah, if your switch goes down, you can probably get by. Yes, you won't be able to stream Netflix or do whatever you want to do, but you'll be able to get by. Your life will continue to go on. But once again, if you're in a larger company where you rely on that network, you are in the financials or in the health industry, your job requires that network to be up. And so we add all this redundancy in there. Now, at layer 2, we can get some loops. When this loop happens, we have some problems that happen. We get some MAC address table instability because this data is circling around and the switch sees the packet once and adds in the information. And then it loops around again and we see it again. And so now we add in, well, that packet came from here, but we just sent it out here, and it's starting to get confused. Link saturation, because this data is circling so much, and because when a switch gets in a piece of data, it doesn't know where to send it, it sends it out all the other ports in which it, except for the port it received it in, it's going to have multiple copies of these packets flowing around, and eventually that link is going to get just so full, nothing will get through there. And because of that, because of all these extra pieces of data floating through your network, the CPU on your switches, on your routers, they're just going to get overloaded saying, I have so much data here, I can't process it all in a proper time frame. Now, layer 3 protocols, IP version 4, IP version 6, they have a process to stop this. What they do is they limit the number of times it can go through a networking device, the number of times it goes through a router. When an IP version 4 or IP version 6 packet gets sent out, these packets, IP version 4 gets a time to live, a TTL, IP version 6 gets a hop limit. Every time it goes through a networking device, a router, it decrements these fields by 1. Typically fields are like 128 or 256. Goes through a router, it takes it down to 127. Goes through another router, down to 126. And eventually, if it goes through enough routers, it will get down to 0. When it gets down to 0, a router sees that the time to live or that hop limit is 0. That router will discard it. It'll delete that field. Layer 2 doesn't have anything like that. That's why we bring in the spanning tree protocol. It's another protocol that works in conjunction with our layer 2 Ethernet. Layer 2 loops. Without spanning tree enabled, we're going to have a lot of broadcasts. We're going to have a lot of multicasts, and unknown unicasts are going to loop on our network and go around and around and around, and we're going to have those problems we just talked about. That MAC address that MAC address table will constantly be updating and updating and updating because of all these updates and keeping track of this information, your CPU. And basically, your network is going to crawl. It's going to slow down so much you can't actually pass usable data through there. One of the big things you hear people talk about with these loops is causing a broadcast storm. A broadcast storm is when we have a really high number of broadcasts. How this works is this broadcast comes into the switch. The switch sees it's a broadcast and it floods it out all the other ports except for the port it came in on. It floods it out, and if there's a loop between the switches, then it's going to start flooding and flooding and flooding. It's just going to overwhelm all the hardware. And a lot of times a broadcast storm is a sign you have a network interface card, network interface controller that is causing problems. It needs to be replaced, needs to be updated, a new driver, something like that, or there's a layer 2 loop. Layer 2 broadcasts, like an ARP request, where we're looking up the MAC address of a device. It's a common issue. They're forwarded the same way broadcasts are, and they can start looping and looping and looping and growing the number exponentially on your network. In IP version 6, the packets are never forwarded. It has a completely different process. IP version 6 packets are never forwarded. The operating system just does not forward them. It's part of the operating protocol. ICMP version 6, neighbor discovery, it uses layer 2 multicast. It's not accessible to the other hosts on the neighbor. On Cisco switches, spanning tree protocol, STP, is enabled by default. And so when you plug in multiple switches to each other and you create a loop, by default, STP is on and it's going to stop that loop from happening. If you like this episode on the purpose of spanning tree protocol and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website here at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Back in 1985, a gentleman at Digital Equipment Corporation, it's called DEC, he published a paper on the idea of the spanning tree protocol and how we do that. And he said we need to come up with a loop-free technology that where the switches, they can determine what the best path is and then block out all the other paths there. Once we have these ports blocking, we have the best path to our destination. But if that path for some reason gets interrupted, then these blocking ports, they can come out of their unblocking state by themselves, recover, and we can give a good path to the destination for our information. The spanning tree algorithm creates a loop-free topology in 4 steps. The first step is it selects a root bridge. The second step is it blocks those redundant paths. The third step is it creates a loop-free technology. And then the fourth one, it does a recalculation in case there is a link failure. The spanning tree protocol is really important when you want to have redundancy in your network. You want to have backup links, backup paths, backup switches. But this causes potential loops in the environment. In this case, the spanning tree protocol has recognized there's a loop in this environment. That loop is connecting all the switches, switch 1 to switch 2, switch 2 to switch 3, switch 3 to back to switch 1. That's causing a loop. And spanning tree protocol has shut down one of those links. It has shut down the link between S1 to S3. This is what we want the spanning tree protocol to do. Right now, when PC1 pings PC2, it takes that pathway. What happens if that link goes down between S1 and S2? In this scenario, spanning tree protocol will recognize that the link is no longer there, and it will take that blocked port and change it from blocking to forwarding. And now we have our alternate path to reach PC2. And redundancy has been achieved. What happens when we don't have spanning tree protocol? S1 will forward a packet to an unknown destination out of both ports, except for the one it came in on. The packet will reach PC2, but notice S2 and S3 are similarly forwarding the packets, and the packet is going around the switch network. A second version of the packet hits destination PC2, even though it already got the first one. Notice the packet's going back to S1. S1 is now getting false information into its CAM table as to the location of PC1 and PC2. PC1 receives the packet it sent to PC2 back at itself, and the process begins again, duplicating on the network. PC1 and PC2 keep receiving duplicates, and S1 and S2 and S3 are confused as their CAM tables continue to fluctuate, causing an instability in the MAC address table. This will eventually shut down all communication on the network, causing a layer 2 broadcast storm. This is what happens when we don't have the spanning tree protocol. If we turn the spanning tree protocol back on, order is restored, redundant links are blocked, and we have a path through the network. Let's test this out on a network. Here's a network set up to mimic what we just talked about, the network. There are 3 switches. Creating a loop in the network. The loop travels between all 3 of those. For this example, we're going to be located down here at PC1. This is where we are located. For this example, we're going to be working from PC1. This is where all of our commands will be originated from. This has an address of 192.168.1.100. And there'll be a second PC located up here off of switch 2 at 192.168.1.100. S2 is what we call the root bridge. Here, S2. S1 down here has an alternate port in blocking mode. We signify that with the red circle with the line through it. Let's take a look at what's going on, and then we'll disconnect that connection between S1 and S2. We'll disconnect that cable between S1 and S2, and we'll see if Spanning Tree Protocol then recognizes that that link went down. And then reactivate that port on S1 and take it from blocking to forwarding. And this adds redundancy, allowing the packets to travel to its destination. Let's first verify that everything is working. I open up my command prompt, and then I ping that FAR computer. As you can see here, I sent my ping out. I got 4 responses back. Everything is working. I also have a console connection using PuTTY connected into S1. Here in the console, I'm going to log in, enter in my passwords, and then I'm going to enter in the command show spanning tree VLAN 1, and it'll give me information about the spanning tree for VLAN 1. You can see the root ID and the MAC address of the root bridge. This is not the root bridge. You'll be able to see how we know it's the root bridge on coming up here shortly. This switch, if we look down here at the bottom, has port 2 in the alternate role and has the status in blocking mode. Once again, we are switch 1 right here. And this port is blocking. What I can do now is from S1, I can telnet over to the root bridge, the boss switch. We'll log in, and then we'll verify that it is the root bridge. Once again, we enter in the command show spanning tree VLAN 1. And right here, you can see that it says this bridge is the root. If it doesn't do that when you do the show spanning tree, that switch is not the root bridge. It has to say this bridge is the root. And because we're the root bridge, notice all of the ports, they're in forwarding mode. You can forward out all of their ports. Okay, I'll exit out and go back to S1. And now what's going to happen is we're going to disconnect that Ethernet cable that goes between S1 and S2. That's the connection that was active. We're going to just disconnect that Ethernet cable. And then we get a system update message that says a link just went down. That's the link we just unplugged that goes between switch 1 and switch 2. And we'll again do the command here, show spanning tree VLAN 1. And you can see down here, we have lost the switch port. There are only 2. There used to be 3 here on switch 1. And now it says that port 2 here is in learning mode underneath the status column. We are now in learning mode for port 2. It is changing from blocking to, if you notice port 2, to learning. And if we enter in the command right again, we can see, I entered that same command in here, and now we can see it's forwarding. We went from blocking to learning to forwarding. Let's go ahead and see if I can still ping PC2 from PC1. Open up my command prompt on PC1. I ping PC2 the second time right here. And as you can see, we successfully did it. We sent 4, we received 4. They came back all good. We got all echo responses back, all 4 of them. Except now, the path it's taking with the link that's broken, remember we broke this link here, we unplugged that Ethernet, the path now goes from PC1 to switch 3 to switch 2 to switch 1. STP, spanning tree protocol, adapted to that one connection going down, giving us redundancy. It was my pleasure to provide you with this wonderful episode on the purpose of spanning tree protocol. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials. In the bottom right is one of my favorite episodes that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.